Hello and welcome to the Calculus Building. My name is Gregory Carlson, and now that we've talked about the definition of the derivative and differentiability, we're going to find the derivative of a few functions using the definition, and so I'm just going to go through the examples and show you how to do them. So here's our function, and they want us to find the derivative, f prime of x, and again notice this little apostrophe right there. That means the derivative in Newton's notation. Let's go ahead and graph this really quickly. So the way you graph this is the vertex is equal to negative b over 2a. So that would be negative 7 over 2a, which would be 2 times 2. So that would be these two negatives become a positive, and so 7 divided by 4 is 1.75. So that would be the x part of the vertex, 1.75. And you should have learned that in your previous classes, either Algebra 2 or Pre-Calc. Now let's figure out the y part. So we'll do 1.75 squared times 2. So that number is 6.125 minus 7 times 1.75 is 12.25 plus 5. So let's calculate that. So we got 6.125 minus 12.25 plus 5. So I get that the y part of the vertex is negative 1.125. So let's graph that. 1.75, negative 1.125. That'll be about right there is my vertex. Okay, and it's going to be a kind of, I'm just going to sketch this. It's going to be a kind of steeper parabola because of the 2 right here in front of the x squared. And I already have a hint on what I think the derivative is going to be. I think the derivative is going to be negative at f of 1. I think the derivative is going to be negative, and I think it's going to be fairly close to 0. So we'll see if my prediction is correct. The way I made that prediction is we want to find what is the instantaneous rate of change at 1. And you can see that on the graph right there, my derivative is going to be negative, and we're getting close to where the graph flattens out. We're not up here on the steep part. So I think it's going to be fairly close to 0 and negative right there. So let's see if that's true. Let's find this derivative before we calculate f prime of 1. So the derivative is equal to this limit. And let's do it. So f of x plus h, you just plug in x plus h up here. So 2 times x plus h squared minus 7 times x plus h plus 5. And minus f of x means we're just going to subtract f of x. And hopefully by now, sorry about that glare, let me turn off my light. And hopefully by now you know that we need to put that in parentheses. So minus 2x squared minus 7x plus 5. And all of that's over h. So that's the limit we're going to calculate. It looks pretty bad, but it's not going to be that bad. So let's simplify. So remember, this is x plus h times x plus h. So we get 2 times x squared plus 2hx plus h squared. And that's just the FOIL of that right there. Do the distributive property, so minus 7x minus 7h plus 5. And then distribute the negative sign. Minus 2x squared minus 7x plus 7x minus 5 all over h. So all I did there was just some simple algebra, distributive property, and FOIL. I already see some stuff cancels. I see that 7x cancels negative 7x, and 5 cancels negative 5. So now let's do this distributive property. We still have our limit out here. We haven't evaluated it yet. So this will be 2x squared plus 4hx plus 2h squared. Okay, minus 7h minus 2x squared all over h. Okay, hopefully all of that makes sense. I see negative 2x squared cancels with 2x squared. And this is what I have up here. And I need to get rid of this h. And I notice that luckily all the terms in the top have an h. So let's factor out an h out of the top, which gives me 4x plus 2h minus 7 on the top, all over h. H cancels with h, which is really nice. So now we get 4x plus 2h minus 7. And now that all of our h's are behaving, we don't have 0 in the denominator anymore, we can go ahead and apply this limit. And so h goes to 0, so that entire term disappears. And so we get that the derivative of our function is equal to 4x minus 7. There's the derivative. So in other words, on this parabola, okay, on this parabola right here, the instantaneous rate of change at any point can be found by just plugging in that point's x value into this function right here. And what I'd like you to try to do is notice the connection between this function and the parent function. Do you think it might be possible to go straight from here to here? I'll let you think about that. Anyway, let's go ahead and find f prime of 1, which is what they wanted. So the derivative at the point 1, I plug in 1 into my derivative function, and I get 4 minus 7, which is negative 3. So remember my prediction? I thought that the derivative of this was going to be negative and kind of close to 0. I think my prediction came out to be true. The instantaneous rate of change at that point right there, the slope of this tangent line, is equal to down 3 over 1, down 3 over 1 at this point of x equals 1. That's the power of the derivative. So I hope that entire process makes sense. You will get it with practice. Let's start the next one, and we'll probably finish it in the next video. Here's a new function, 4 divided by x. It's going to be a hyperbola, and they want us to find derivatives of 0 and 2. So I'm going to graph it really quick. Just by plugging in some points, I see that I'm going to be an asymptote at 0 and a horizontal asymptote at 0. And if I plug in 4, I get 1. If I plug in 8, I get a half. If I plug in 1, I get 4. So I'm just plugging in points for x so I can kind of sketch the graph a little bit. And we're going to get the same exact thing on this side. If I plug in negative 1, I get negative 4. If I plug in negative 4, I get negative 1. So here's just a rough sketch of the graph. Okay, so what do we think these derivatives are going to be? Well, hopefully we're going to get undefined in our derivative function when we plug in 0, because we're undefined right there. So we'll see what happens with the derivative function. And if I plug in a 2, what's the slope right here? Well, what's the instantaneous rate of change? What's the slope of that tangent line that's hitting our hyperbola at 2? It looks to me like it should be negative. I don't know, maybe negative 1? Negative 2? Not really sure, but it should at least be negative, it looks like. So let's calculate the derivative, and this might be a little tricky, so I'm going to show you how to do it. The derivative is equal to our limit as h goes to 0. F of x plus h is going to be 4 divided by x plus h, right? Because I just replace x with x plus h, minus 4 over x. Because that's just f of x is just 4 over x all over h. Okay, we've done a problem similar to this one already, but as a reminder, first we need to combine these two fractions, and we have to do that, we can only do that when we have a common denominator. So the trick to that is to multiply this side by x plus h over x plus h, and multiply this side by x over x. Okay, and what that does is, so where did I get? I got the denominator of this one that I times this one by, and the denominator of this one I times this one by. And that's going to give us the following. And that's a little trick when you're doing these hyperbola ones. I know that my denominator is going to be the same for both, and it's going to be x times x plus h. And the numerator is going to be 4x minus 4 times x plus h. And all of this is still over h. So I didn't do anything too tricky there. I just did a little trick so that I could combine these two fractions with the same denominator. I see that my video has just passed 10 minutes, so let's go ahead and complete this example in part 2, and I will see you right there.